We want to look now at graphing ellipses. So just to recall from what I had you take notes on from your book, here's my two formulas for ellipses. So when we graph them, based on the formula, we have to first determine our orientation. Is it going to be stretched horizontally or vertically? We have to find our center, and then we can use our A and our B to then plot the distance from the center to one of our endpoints. So looking at example 1, I want to go ahead and graph this ellipse. So first thing I notice is that my center, very similar here to a parabola or a circle, my center is going to be at 3, -1, because once again I am subtracting my h and subtracting my k, so I do want to take the number that's being subtracted, where here it's a 3 and here +1 is the same thing as -1, so this is my center. I also need to know my orientation. So again, is it stretched vertical or stretched horizontal? And so looking at this, my A is always bigger than my B, so it looks like my x squared term is over the larger number, which tells me it's stretched horizontally, so I usually just draw it rather than writing out the word, so I know it's going to look something like that. I know that my A is the square root of the larger denominator, so the square root of 36 is 6. And my B is the square root of the smaller denominator, so square root of 9 is 3. So in order to graph this, I'm going to go ahead and plot my center over 3 down 1. And then from there, I'm going to go ahead and take my A, and I'm going to go horizontally 6, and then I'll go vertically 3. So horizontally 6 gives me 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then vertically 3. And again, I know to do that because of the orientation, because the x squared term is above the larger value. Then I'm going to go ahead and connect it in as smooth as motion as possible here. And I know mine's probably going to look a little, that's actually a pretty good ellipse. I'm kind of impressed with that. So there's my graph of my ellipse. So notice I didn't need, I know when you took notes, you saw there was a foci and some different equations that related the A, B, and C, the C being the distance from the center to the foci. So notice that in graphing, I don't need that. So in the next video, when we start looking at writing equations, that's when that will come into play. Going ahead and looking at example 2, I believe there are only 2 examples, if I'm remembering right. So same thing, but notice this time I'm not given it in standard form, so I'm going to have to use that skill of completing the square to do that. So I'm going to go ahead and go through the completing the square. I'm going to factor out a 4 out of my x squareds, and I'm going to bring the 3 over. And I'm going to go ahead and take my linear term, divide by 2, and square that result so I can add that to each side. I'm going to do that for both variables, giving me 4 times x squared plus 6x plus 9 plus y squared minus 10y plus 25 equals 3. I do have to add to both sides, keeping in mind that this 9 is being affected by this 4 here, so I am going to add a 36, and I'm going to add a 25, giving me, I'm going to go ahead and complete this square, x plus 3 squared plus y minus 5 squared does equal 64. Again, an ellipse has ellipses are equal to 1, so I'll divide both sides by 64. Giving me x plus 3 squared over 16 plus y minus 5 squared over 64 equals 1. And now I'm ready to go ahead and gather my information needed to graph it. So first of all, I'm going to see that y is over the larger number, so my orientation is going to be stretched vertically. I'm going to go ahead and have a center of -3, 5. My A, remember, is the square root of the larger number, so my A is 8, and my B, or the distance from the center to the minor axis, is going to be, or the endpoint of it, is going to be the square root of the smaller number, giving me 4. So I'm going to go ahead and plot my center, and then because I'm stretched the long way, I'm going to take the longer number, so I'm going to go vertically 8 in each direction. I think I counted that right. And then in the upwards direction, I know I don't have enough room on my graph, so I'm just going to go up a little bit above. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, maybe like about here. And then I'm going to go horizontally a distance of 4 from the center. And again, I'm going to connect those with as smooth of line as possible, and there's going to be my second ellipse. So again, make sure you did take notes and you did get this information down because it's going to be extremely helpful when graphing these ellipses. Bring these note templates in with you or bring your notes in with you so we can discuss any questions you have in class.